G'day, this talk is about breaking down query latency for MySQL and Percona using Dtrace. I gave this talk at PerconaLive in New York. I'll talk about Dtrace and dynamic tracing briefly, and then latency and query latency, and breaking down query latency components such as on CPU and off CPU. I'll use file system latency as a core example, and I'll mention other things that are interesting like InnoDB thread concurrency latency. My name is Brendan. I do performance analysis. I write a lot of performance tools. And there are over 200 scripts in the Dtrace book that I wrote with Jim Marrow. But I do write these tools out of necessity. I work at Joint, and we do cloud computing. And I'm frequently writing tools to solve real-world problems. We have many customers and instances of MySQL, hundreds of instances of MySQL running. And we're now offering smart machines with Percona, just to show that that's real. There's the Joint Percona smart machine page, which you get sent to when you get a smart machine with Percona installed. And we're encouraging people to use Percona because we care a lot, and our customers care a lot about performance and scalability. We use Dtrace. We use Dtrace to make sure that our environments are getting the best performance possible, and that we're able to answer all questions about performance, exactly why things are slow or how things can be improved. As a very quick rundown on Dtrace, a lot of people know this by now. Dtrace is a performance analysis and troubleshooting tool. It allows you to see inside user-land applications, such as MySQL, and also to look inside the kernel from the same tool. That's particularly important because there can be many issues that are inside the kernel. And with Dtrace, you can watch it from query context down inside the kernel and back again. It's production safe. It's been in use since 2005. The language is fairly easy to learn. You can learn the language in about a day. It's inspired from C and awk. The difficulty of Dtrace is learning how to apply it, which is something I'm going to be talking about a lot through this talk. Dtrace is currently for Solaris-based operating systems, such as Solaris 10, Joint's SmartOS, Illumos, and others. Mac OS X has got Dtrace, so Dtrace is running on my laptop right here. FreeBSD, and there is a port of Dtrace to Linux. You can check out that blog to find out the current status, which seems to be coming along pretty well. Another way to introduce Dtrace is to explain who uses Dtrace. So at the command line, people such as system administrators can use Dtrace to understand the usage of the resources, the things that they're in charge of. So how well are my disks performing? Exactly what workload are they performing? What are they being requested to do? And use that information for capacity planning to know when to purchase more disks, when to reconfigure things. And also for the other resources that system administrators are in control of, such as CPU, memory, and network. Database administrators can use Dtrace at the command line to investigate the internals of the database. This isn't going to be the first tool that database administrators are likely to use. They often have various high-end tools that give summaries and reports about what the database is doing. Dtrace complements them by allowing you to go much deeper when required and to go inside the code of MySQL to find out exactly where things are slow, to pinpoint latency. Developers can use Dtrace at the command line to understand latency. As they're making changes to their code, they can find out how those changes perform and exactly if they've aggravated any code paths. At the command line, people will use Dtrace either by writing scripts or by running other people's. I wrote a collection of Dtrace scripts called the Dtrace Toolkit. A lot of people get value out of Dtrace by running my scripts from the Dtrace Toolkit. They don't write the scripts themselves. Or they may take one of my scripts and customize it a little bit for their environment, which is great. So you don't actually need to sit down and write Dtrace scripts in order to get value from it. You might be running other people's, like the Dtrace Toolkit, or the Dtrace scripts in the Dtrace book. Another practical approach may be to hire or assign a Dtrace guy if you've got a team of database administrators or developers or system administrators. Just pick one person on the team to learn Dtrace, and then other people on the team can make requests of that person. As part of becoming very proficient at Dtrace, you will learn a lot of different topics, such as kernel internals as required, application internals, and practically that's not something that everyone on the team needs to do. So you can pick someone who will learn that and be able to answer those questions. Everyone provides them the questions to answer. So a lot of people will be using Dtrace indirectly. This includes people who are using Apple's Instruments, which has Dtrace at the back end. At Giant, we're developing something called Cloud Analytics, which provides visualizations on top of Dtrace so that you can analyze performance by using a graphical interface rather than going to the command line and typing in scripts. And we'll see other front ends built on top of Dtrace over time. Dtrace is different. So we live in a world where there are a lot of performance tools. This is not just another performance tool. It is the first implementation of dynamic tracing. And understanding this is crucial. It may not be the last implementation of dynamic tracing. So on Linux, there was a project, or is a project called SystemTap that's trying to do the same thing. There could be others in the future. Time will tell. Dtrace itself, hopefully, I'd like to see it ported everywhere, and I'd like to see that available on Linux and available on Windows. But I can't predict the future. In 10 years from now, there may be a whole different tool that does dynamic tracing. The most important thing for us to learn about is dynamic tracing and what dynamic tracing brings to performance analysis. At the moment, Dtrace is the way you get that, the most common implementation that works on those environments. Dtrace, as an implementation of dynamic tracing, it also does static tracing as well. That's very useful, it's very practical, and let me go through a couple of short demos. So dynamic tracing of MySQL, here I've run Dtrace at the command line. I won't go through the syntax of Dtrace a lot. Like I said, you could actually learn Dtrace in about a day. This is running Dtrace -L to list probes, and then it has a probe definition. A probe is an instrumentation point that can be dynamically or statically created. When enabled, it allows you to collect information on a running application or the kernel. For example, and the output here was over 22,000 lines, so this is just a very brief summary. Probes are constructed out of 4 parts. We've got the provider name, module, function, and name. Here is a probe for MySQL send query, for when that function begins. It's the entry probe. Here's a probe for MySQL real query, MySQL real connect, MySQL store result. Here's some other functions, OS file write and OS file read, which come out of InnoDB. Here are some libc functions, strlen, strn, cmp, which might be very familiar if you're a C programmer. Dtrace has the ability to see the execution of any of these by creating a probe point or a point of instrumentation when those functions begin executing. How that works, and this is why it's the dynamic part of dynamic tracing, is you have an application that's running. Dtrace is able to look at the symbol data for that application. That application, by the way, it doesn't need to be compiled in any special way. I can walk up to a production server that's running MySQL and has been for 100 days. Now it's got a performance issue and we need to investigate it immediately. Without restarting it, without rolling a different patch, we need to investigate it right now. Dynamic tracing can go to the symbol table for that process, find the addresses of the functions, and change the instructions in memory so that when these functions begin executing, the CPU will jump to a different area, perform some metrics, record some information, and then return back to the normal flow of the program. How this works exactly, and to be clear, it is dynamically patching the program. So we're going to the instructions of a live production application, and we're changing the instructions while the application is still running. This sounds kind of insane. It is kind of insane in a way. It is also the reason why it was very difficult and tedious for the engineers to make sure that it was safe for production use. It required a few years of engineering time from the best engineers at Sun Microsystems, and they came up with a model so that it was production safe. You could actually do this. Insane as it sounds, to walk up to your precious production server and start changing instructions on the fly, it does work. And the model it's been designed about, this is one of the design principles of Dtrace, is to allow you to do that so that you do feel safe about using it in production. That's not to say you can't hurt yourself by using Dtrace in production. Dtrace is great for instrumenting a few things and answering questions. If I were to instrument every function inside MySQL, for this version I can instrument 22,000 functions and then collect a lot of information for each of them. Just the extra overhead of all those functions, which may be a million instrumentation points a second, that will start to add up and start to be significant. So with Dtrace you can slow down the application if you do too much. Most of the time I'm using it, I'm only picking a few things to answer specific questions, and it works great. And the performance overhead is negligible. In order to be able to write programs that use these functions, you do need to have an understanding of the source code. And the source code itself is not really documented anywhere. You may get a MySQL internals book where you find some of the functions are described, but generally the only source of documentation for many of these will be the source code itself. Another problem with it is that the functions change from one version of MySQL to the next. If you're the software engineer writing MySQL and you want to rename one of these functions, you just rename it. It's not an official API. Well, some of them are, but many of them are not. And if someone has written Dtrace scripts that expect those function names to stay the same, then those scripts will break. So there is a disadvantage to dynamic tracing. It's great in that it exposes everything. In this case, over 22,000 probes, and that's just the entry probes. I can also do the return probes for when functions finish. That stuff is great, but this isn't for absolutely everyone. Not every system administrator is going to be instrumenting the internals of a MySQL database. Not every application developer. So as a different means of allowing people to get value out of Dtrace, Dtrace supports static tracing. With static tracing, the source code itself is modified so that interesting places have a macro added that will call Dtrace and provide an instrumentation point or a probe. I say interesting places, things like query plan start, query plan finish, query execute, flush log start, flush log finish, and so on. There may only be about 30 of these presented from MySQL. An advantage of the static probes is that they are documented. So as part of the MySQL reference manual, here I'm looking at the 5.7.1 MySQL D Dtrace probe reference, and there's numerous categories of probes: connection probes, command probes, query probes. And for each of these, it does document what they do, what their arguments are. So here's connection start and connection done. Connection ID, user, host, and connection done has the status. This is great in that you don't need to understand the internals of MySQL in order to write Dtrace scripts. And also, since it's a documented interface, the intent of these stable probes or static probes is to be stable. So that when I write, say I write a collection of Dtrace scripts that my company would like to run to answer various questions, those scripts will continue working across different versions of MySQL because this interface won't change. That's the advantage of it. It's much easier to use, much easier for people to pick up and develop scripts for. They don't need to understand the internals. And it actually does the hard work for you and give you the important information without you having to search through the internals of the application. There is a disadvantage to these static probes, however, and that is they may not be available. I started by saying it required a source code change. So for MySQL to present these, it has to be compiled with ---- enable Dtrace, and those Dtrace macros must be inserted inside the code. When I wrote the Dtrace book, I thought that the static MySQL probes were pretty common. They had existed in the places I had seen MySQL running within Sun. Now that I'm working at Giant, I'm on cloud computing. Lots of different customers are running lots of different MySQL versions, and it's hit and miss. Some customers have these available, and some customers don't. And if you don't have these available, you still may have performance issues you'd like solved. That's where dynamic tracing can still help out. So dynamic tracing is always there and can provide all sorts of internal information about the application. Static tracing is nice to have if it exists, much easier to use. I have a slide just to summarize those points. Static is better when it's available, but it is limited. Like any traditional pre-Dtrace metric, there's only a certain number of probe points or events that you can monitor and instrument. Dynamic tracing is the catch-all. It works on old and new MySQL versions. It doesn't matter whether the static probes have been compiled in or not, and it can see everything. I currently spend more time using dynamic over static tracing of MySQL. This should change in the future with the addition of more static probes so that some of the common things that I'm investigating can be detraced via the static set. So over time, it will become easier and easier because there will be more static probes. The term dynamic tracing, to make that clear and to separate it out from Dtrace, which I have by now. So Dtrace is an implementation of dynamic tracing. It's proven the concept. It has been used in large-scale production for over 5 years. Dynamic tracing, it's important to think about that because it provides a new perspective. What metrics would I like? Instead of the vendor picking, say, a collection of statistics to export via a tool, or maybe you're using the performance schema and it has a fixed number of events that it can monitor. It might be 100 events. With dynamic tracing, you can see everything. You can see the entire execution of all software. MySQL itself, the libraries it uses, the storage backends, the system calls, the kernel, the device drivers. You can see everything for all tools. Given that capability, you can then start to entertain questions such as, what metrics would I like? This is perhaps one of the most difficult things for people learning Dtrace. It's not the language. Like I said, the language can be learnt in a day. It's getting your head around the mentality of Dtrace, or the mentality of dynamic tracing. Given the ability to be able to measure anything I want, what would I like to see? What would I like the system to report upon? And something that is important to measure is latency